of events. So for this session, we will be dealing with determining the union and intersection of events in terms of relative frequency. So first, what is union? So union is basically the sum of the elements from the given set. So this is what we are to do whenever that we are asked to find the union. So it is denoted by the symbol U. For intersection, to get the intersection between two sets, so we just simply find the common elements from the given sets, or we may find or to look for the common area or region. So that will serve as the intersection. For the symbol, so we use the inverted U. So let us deal with three sets of examples dealing with Venn diagram in table form or in set builder form. Let's have this data in terms of Venn diagram. So the data below shows the number of students of Gitan Diamond who participated on the following sports. So we have the basketball, the volleyball, and the softball. So let us first determine the data from this set or figure. So the number of students who participated in basketball, so denoted by letter B, and those are these numbers, these quantities. So 13 plus 2 plus 1 and plus 3. So upon adding these numbers, so therefore the number of students who participated in basketball is 19. Next one. How about the number of students who participated in volleyball? So we just simply count again those quantities or frequency that are within the area of volleyball. So we have 11 plus 2 plus 1 plus 2. So denoted by letter V. So, and there are 16. How about the number of students who participated in softball? So again, it is as simple as counting all of those quantities or frequencies within the softball area or region. So we have 6 plus 2 plus 1 plus 3, and the answer here is said to be 12. Okay, so let us now deal using the symbol for union. Let us have this one. For number of students who participated in basketball or volleyball. So we may represent this as B union V. So since there's the word or, and the word or means union. So in determining the union between two sets, so we just simply add up all of those numbers or frequencies involved within those two areas. So we are to add up 13 plus 2 plus 1 plus 3 plus 11 plus 2. So these are the numbers that we are to add up because these are the elements that are within the area of basketball as well as volleyball. And that gives us the sum of 32. So for the next one, number of students who participated in volleyball or softball. So we may represent that as V union S. So V for volleyball, S for softball. So again, we do have the symbol for union because the word used is or. Again, or represents union. So this time, the involved area is the area for volleyball and softball. So we are to include or to add up all of the numbers within this region or within this area because we are dealing with union. So union means combining all of those elements. So we do have 11 plus 2 plus 1 plus 2 plus 3 and plus 6. And the answer is 25. Last one, number of students who participated in softball or basketball. Again, the word or means union. So we may have the representation S union B. So softball and volleyball. So union, again, we are going to use all of those elements or data that are within the region of softball and basketball. So therefore, we do have 13 plus 2 plus 1 plus 3 plus 2 and plus 6. So therefore, the answer is 27. So that is how easy to determine the union between sets. Let's have another one. This time, let us deal with intersection. So for number 7, number of students who participated in basketball and volleyball. So as you notice, this time the present word between the two sets is and the word "n" denotes intersection. So we may represent this as basketball intersection volleyball, or B intersection V. So upon looking at the diagram or the figure that we do have, so these are the areas that are involved. But keep in mind that since we are dealing with intersection, the values or the elements that we are going to use are only the elements that are being shared by these sets. And these are the numbers 2 and 1. So this is the area shared by volleyball and basketball. So therefore, we are just only going to add 2 and 1. So 2 plus 1, the answer is 3. So that is how we operate in terms of intersection. How about for number 8? So for number 8, the number of students who participated in volleyball and, again, there's the word "and," which means intersection. Volleyball and softball. So we may have V intersection S. So V for volleyball, S for softball. So between volleyball and softball, upon looking at the figure, the area that they are sharing is this area, wherein the numbers involved are the numbers 1 and 2. So these are the only numbers to add up because we are dealing with intersection, only common area or common region. So 1 plus 2, so the answer is 3 as well. Next one, for number 9, number of students who participated in softball and baseball. There's the word "and" again, so therefore we will have S intersection B. So looking at S for the softball and the area for the basketball. So the common region or the common area shared by these two circles is this area or this region involving the numbers 1 and 3. So therefore 1 plus 3, so the answer to our number 9 is 4. Okay? So hope it is clear how to solve problems using intersection and union. Let us have a different set. This time, let us deal with in tabular form. So the data below shows the number of students who registered for the modality of the class they want to attend. So first, let us have the basic information. So the number of boys who registered. So here is the area or the numbers that are covered for the boys. So we just simply add up all of this. So 16 plus 45 plus 18. So that is how we do it. We answer it. So therefore, the answer is 79. While for the numbers of girls who registered, so for the girls, these are the numbers covered. So 40 plus 14 plus 20. So the answer is 74. Next one, number of students who registered in online class. So for the online class, so these are the numbers involved, 16 and 40. So 16 plus 40, so that gives us 56. Next one, number 4, number of students who registered in modular class. So these are the numbers covered by the modular class. So 45 and 14. So the sum here is 59. While for the number of students who registered in face-to-face class, which are the numbers 18 and 20. So 18 plus 20 is 38. So let us now use union. Let us see how are we going to find the union between the given sets. So for number 6, the number of students who registered that are boys or in face-to-face. So or means union. So we may denote that as B union M. So for B, for the boys, so these are the numbers involved. And for the face-to-face, here are the numbers involved. So just like the idea that we did in Venn diagram, since we're dealing with union, so it is as simple as adding all of those numbers that are involved. So we do have 16 plus 45 plus 18 plus 20. So that's how we find the union between the given sets. And there, the answer is 99. So we are doing the same idea, the same concept. Union means adding up all of the elements involved. Let's have the next one, number 7. So let me erase this. So for number 7, number of students who registered that are girls or in modular. So that are girls. So these are the numbers for the girls. Or, so or means union. Then modular, these are the numbers. So for us to find the union between these two, again, we just simply add up all of these numbers involved. So we do have 40 plus 14 plus 20 and plus 45. So upon adding those numbers properly, correctly, so that gives us 119 as the union of girls and or in modular. Number 8, the last one for the union in tabular form. So number of students who registered in online class or in face-to-face. So we just simply look at the numbers of students who registered in online class, and they are here. So 16 and 40. Then in face-to-face, 18 and 20. So they are, even if they are not connected to one another, since union is just only a matter of adding all of those elements, so we just simply add these numbers. So we do have 16 plus 40 plus 18 plus 20. And that gives us 94. So remember, in union, it is not necessary for the elements to be connected. Let's have intersection now in terms of tabular form. So for number 9, number of students who registered that are girls and in online. So N means intersection. So we do have G intersecting O. So G is for the girls. So this is for the girls. And O is for the online. So these are for the onlines. So, but since we are dealing now with intersection, so we are not going to add up all of these numbers. In the intersection, what we just simply need are the shared area or shared element. And upon looking, the shared element or area is just only this region. So we do only have number 40. So therefore, the answer for this one is 40. For number 10, number of students who registered in face-to-face and a boy. So we may have F intersection B, F for face-to-face and B for boy. So for face-to-face, we do have these numbers or this area. And for the boys, we do have this area. Since we are dealing with the intersection again, so what we just simply need is the common area. And we do have here 18. So therefore, the answer is 18. Last one, number 11, number of students who registered in online and in modular. So in online, so here is for online. And for modular, here is in modular. Again, we are dealing with the intersection because we do have the word and. And upon looking, we don't have intersection between online and modular. So it is required for us to have the intersection. There should be a common area or common elements. But in this case, we don't have. They didn't manage to intersect. So therefore, the number of students who registered in online and in modular, the answer is 0. So hope you understand. Now, so let us have a different set. So let us have now here. So by the way, we call this manner of representing set as roster notation. So correction, not a set builder form. So for set E, we do have A, B, C, D, E, F, G, H, I, J, K, L. For B, we do have A, E, I. For C, we do have A, B, F, G, H, I, L. So compared to the first two sets, so here, this time, our elements are not in frequency or not in quantity. So they are listed already. So therefore, there's a need for us to count. So first, let's have the basic information. Number of elements in set E. So E, so upon counting, so with the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So therefore, we do have 12. For number 2, number of elements in set V. So we do have 1, 2, 3. Okay. And for the last one, number of elements in set C. 1, 2, 3, 4, 5, 6, 7. So we do have 7. So this is the difference of our set today to our third set compared to the previous two. So let us now involve union. So for number 4, number of elements in set E or V. Again, or means union. So we do have E union B. So what we are to do is to plainly add all of those elements. Okay? But remember that we're not going to count the elements 2 times or again once we are done adding them already. So E and B. So we are to add up the elements of E and B. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we're not going to count letter A anymore because we already counted A in set E. So there will be no duplication. So 12, letter E, not either, because we already counted E in set E. And letter I won't be counted anymore again because we already counted letter I on the previous set. So therefore, the union of E and V is said to be 12 only. So whenever that the given sets are not in frequency form, instead they are written in listed form or in roster notation. So keep in mind that you are not going to count the elements more than once. Next, number 5, number of elements in set V or C. So letter V and letter C are the sets involved now to our problem. There's the word or. So again, we will be dealing with union. So V union C. So let us deal with V and C. Union, so we're going to add up the elements. So we have 1, 2, 3. We're not going to count A anymore because we already counted A. So 3, 4, 5, 6, 7. So I won't be counted anymore. Then 8. So we do have 8 elements between V and C. So union of these two will give us 8. Number 6, number of elements in set C or E. So set C and E. So there's the word or. So it means union. When we say union, we're going to add up all of those involved elements. In this case, we are to count it off. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So E and C. Then 12. So A won't be counted anymore, same as B. It is already present in set E. F, not either. G, not either. H, already counted as well, same as I, and same as L. So therefore, C union E, the answer is 12 as well. How about in intersection? Again, in intersection, keep in mind that we just simply count the common elements. So for number 7, number of elements in set V and C. So the word N means intersection. So we do have V intersection C. So V and C. So upon observing the two sets, so the common elements are the letters A and the letters I. So there are only two common elements between these two sets. So therefore, V intersection C, the answer is just only 2. How about for number 8? Number of elements in set E and V. Set E and V. So intersection, and means intersection, so we're just simply going to look or to count for the common elements only. So how many are there? So we do have A, 1, we do have E, 2, and we do have I, so 3. So no more, so therefore the answer is 3. For number 9, so the last, number of elements in set C and E. Set C and E. So we do have C intersection E. So C and E. So upon looking, so we do have A, 1. We do have B on both. We do have F. So third, fourth G, fifth H, 6 I, then 7 L. So we do have 7 common elements between set E and set C. So common elements is for the intersection. So therefore, the answer is 7. So hope you understand now how to deal with notations or problems involving union and intersection. So hope you understand. what I said today. So thank you for watching. So see you next time.